Hello and welcome back. In this video we're going to be going over solving advanced linear equations. And what I mean by that is we're going to be using the techniques we learned from the previous videos to increase the range of linear equations that we're able to solve. And the two main techniques that I went over were collecting like terms and distributing, so we're going to be going over both of those techniques in this video and the next video. So why don't we start off with the very first example. So in this example we have 5 times 3x minus 1 is equal to 2 times negative 2x plus 4. And we always want to think, what's the first step we want to take? In this case, we want to distribute it. We have, on both sides of the equation, we have a whole number multiplied by some expression. And so we want to distribute those whole numbers to each of the terms that they're multiplying by. So in this case, it's the exact same idea we went over from before. So the 5 is going to multiply the 3x and 1, and the 2 is going to multiply the negative 2x and 4. In this case, we'll have 5 times 3x minus 5 times 1 is equal to 2 times negative 2x plus 2 times 4. So those whole numbers are being distributed to each of the terms. And from that point we have 5 times 3x is 15x, and 5 times 1 is 5. So on the left hand side we have 15x minus 5. On the right hand side we have 2 times negative 2x is negative 4x, and 2 times 4 is 8. So we have negative 4x plus 8. And from there, as we discussed previously, we always want to group all the x terms to one side so we can add them up so that eventually we only have one x term. In this case, I'm thinking we can add 4x to both sides. In this case, the negative 4x will cancel out with the 4x on the right hand side, and we'll be left with 15x plus 4x, which is 19x, minus 5 is equal to 8. Okay? And then from there we're just solving for x. So we add 5 to the left hand side, and therefore we add 5 to the right hand side. So 5 and negative 5 cancel out because negative 5 plus 5 is 0. And we have 19x is equal to 8 plus 5, or 13. And from there we can just divide both sides by 19, and we'll have x is equal to 13 over 19. And that would be our final answer. So that specific example made use of the distributing technique that we talked about in the previous video. And once again, I'll add color coding if it helps you better visualize the distributing that we did in the beginning. So 5 got carried to both terms, which were 3x and 1, and 2 got distributed to both terms, negative 2x and 4. Okay, so in this example, you'll notice we have a fraction. And so the question is, how do we deal with fractions that show up in linear equations? The way we're going to approach this question, the very first step we're going to take is to eliminate the fraction, because we don't like seeing fractions, we don't want to have anything to do with fractions, so we're just going to get rid of it. So how are we going to do that? Well, the answer is we're going to multiply the left-hand side of the equation by 3, which means we must also multiply the right-hand side of the equation by 3, and that will give us 3 times 4x plus 2 over 3 on the left-hand side of the equation. Now why is that good? Well, because you'll notice that as part of the fraction we have 3 over 3, or 3 divided by 3, which is what? Well, it's 1. So we can essentially just cancel those 3's out. And on the right hand side of the equation we'll have 6 times 3. So this means we'll have 4x plus 2 is equal to 18, because 6 times 3 is 18. And from there we know what we have to do. We want to get rid of the 2, so we will subtract 2 from the left hand side of the equation, which means we have to subtract 2 from the right hand side of the equation. 2 minus 2 is 0, so those two terms cancel out, and we're left with 4x is equal to 18 minus 2, or 16. And from there we can divide the left hand side of the equation by 4, which means we'll have to divide the right hand side of the equation by 4, The 4's cancel out because 4 divided by 4 is 1. And on the right hand side of the equation we'll have 16 over 4. And therefore our final answer will be x is equal to 4. Okay, so those are the two examples that I wanted to go over in this video. In the next video, we'll continue to use techniques like collecting like terms and distributing to solve these types of linear equations, and we'll also deal with an example that involves multiple fractions. But for now, I hope these examples help, and as always, thanks for watching.